Hello everyone and welcome to another video. Today is just a little short one on the Elma air pressure tester. My name is Travis. I'm the watchmaker here at Mr. Minute Central Watch Repairs. Reason for this video today, we've just had a few questions on people who own this air pressure tester on just some tips and tricks on how to use it. So just in short, what this pressure tester does is measure the water resistance of the watch by measuring the deflection of the case back and the glass. So the physics behind it is it's a vacuum pump, and what it does under vacuum is what will happen is that if it's water resistant, the watch will expand slightly, and this is what this tool is measuring. So if we have a quick look at it, we'll take the bell jar off. So what we've got here at the top is a micrometer, and what it does, it measures distance. So if I put my finger under there, see as I push it up and down, all that it's doing is just measuring how far I'm pushing it up and down. It's not a pressure gauge, so it's not measuring the pressure inside, but what it is measuring the distance that the glass and the case back move. So when it's under a vacuum, what's happening is that the air inside the watch is expanding because the pressure around the watch is lower, so it's trying to equalize. But because the watch is airtight, the air has nowhere to go, so what it does, it pushes on the glass and the case back, and we can measure that using the micrometer here. So just as a little bit of fun, what I'm going to do here is got a little balloon here, and I'm going to see what happens when we put it in a vacuum. So as we watch, you can see under pressure, what happens is the balloon expands, and the micrometer there, as you can see, the dial went up. It's just measuring how much that expanded. So let's put the pressure down. You can see there how we release the pressure, it shrinks back. Now, if I was to put a balloon in there that had a little hole in it, when we put that under a vacuum, the air would escape out of the balloon, and the dial indicator wouldn't move because the balloon wouldn't be expanding. So, same thing happens with a watch. So, let's test out a watch now. So, what we want to do, we want to make sure that the bottom anvil is sitting flat up against the case back. I want the dial indicator to be in the center of the watch. Now, what we want to do, we want to lift up the anvil until it's just touching, and we just want to put pressure on that dial indicator so it's under tension. So we see the numbers over between 1 and 2. Make the dial nice and centered. And we just turn the dial just to zero it in. So let's turn it on. And you can see, as it becomes under a vacuum, the dial's now moving. That's because the case of the watch is expanding, and that's what we're measuring here. So if that watch is airtight, what's going to happen is that when it expands, we can see there now that the dial has stopped. We turn it off. So when the case expands and we turn off the vacuum, if that's airtight, no air should release out of the watch, and that should stay expanded. Now, if we find that that goes back down while it's under vacuum, that means that there's air escaping somewhere and there's a leak in the watch. So if we leave that for a minute or so, we watch that dial indicator. If it doesn't move, it's water resistant. If the dial indicator goes down slowly, that means that there's a slow leak in the watch. And if we find that the dial doesn't move when we turn on the pump, that means that there is a large leak in the watch. So now what we can do, we can release the pressure. We know that the dial hasn't moved. So this one is indeed water resistant. I've also had a few people also ask as well, what happens if the dial drops back below where you zeroed it off? That just means that the watch has moved while you've had it under pressure, and that it wasn't on there flat to start with. So just redo the whole test again. Okay, so I've switched cameras over here. So what we have here is a G-Shock, which is perfectly fine to air pressure test. The reason I wanted to show you this one is we can't sit it completely flat on the anvil because we've got the plastic case in the way, and that's going to affect the reading of the micrometer. So if it doesn't sit flat, there's a chance it's going to move or deflect or compress. So to remedy this, we just get one of the dies from our glass press, and that gives us a stable base to sit it on. So let's swap back over to the pressure tester. So here we are. So we've got that die there. Make sure it's nice and flat. We lift it up. Nice and centered. Zero it off. And turn it on. So the case backs on G-Shocks are quite thin, even though they're quite water resistant. You can see how much that deflects. We'll leave the pump on until we see the needle stop moving. And then we turn it off. So if that needle doesn't move, that's a pass and it's water resistant. But if we see that needle move down, that means that it's leaking somewhere. So we can see that needle's not going anywhere. That's a pass. There we are. So just an example here as well. I've got a diving watch here, and what it has is a very thick glass and a very thick case back. So when you get into high-end diving watches, this machine isn't quite strong enough to measure the deflection. So meaning the vacuum isn't strong enough to deflect the glass or the case back. So if we turn this on, I've got this all zeroed and set up. If we zoom in here, so we can see here that the needle has only measured the tiniest amount of movement. So this is enough to test it. But the reason why it's only detected a very small amount of movement is because that glass and caseback are very thick, and it takes a lot of force to deflect. So now we can release that pressure, and we'll see that needle go back down just the slightest. That was only a micrometer. Now, if in doubt, you can always still wet pressure test. And also, if it fails, the wet pressure test is a good diagnostic tool to actually see where the leaks are coming from. Okay, so a nice short quick video today. So just as a recap, so what the air pressure tester is testing is measuring the amount that the caseback and the glass expand. It's not measuring the pressure, but what it's doing is measuring the expansion, and then we're using that as a diagnostic tool to tell us what's going on with the watch. So as always, thank you for watching. Of course, if you have any questions, please pop a comment down below. Subscribe so we can get more updates to videos. And thank you once again for watching. I will talk to you real soon.